Okay, so for this next video, we're only doing page 3 because there's kind of a lot going on. So, at the top here, so we're talking about zeros now, which we know are the same thing as the x-intercepts. So, it says to identify, so you have this table here, to identify the zeros, the multiplicity, and the effect on the graph. So I just want to explain what we're talking about there. So, I'm just going to use the first example. So we have f of x equals 3x, x minus 1 to the 6th, and then 5x plus 2 to the 3rd. Okay, so I think we are all comfortable with the process of setting each of these to 0 in order to see what x equals, to see what that x-intercept is. Okay, so I'm just going to go and do that. I'm going to disregard those exponents for now. I'm just going to take out 3x, x minus 1, and 5x plus 2. I'm going to set them all equal to 0. Okay. I'm going to get that the x for the 0 here, the x-intercept is 0, okay? X-intercept is 1. X-intercept is negative 2/5. I think we're all good with doing that much. So that fills out your first column of that table. What are the zeros? So my zeros are going to be 0, 1, and negative 2/5. So the multiplicity, that's talking about like how many times is that 0 intercept appearing. So I can rewrite like this 5x plus 2 to the 3rd. I can rewrite that as 5x plus 2, 5x plus 2, 5x plus 2. Okay, we all agree. And I could do that with this one 6 times. Okay, so the multiplicity is telling me how many times this root is appearing in this function. Okay, so the multiplicity for this one is going to be just 1. Okay, there's like a 1 up here, right? Multiplicity for this one is going to be 6. Multiplicity for this one is going to be 3. So your exponent tells you what the multiplicity is. Okay, so the effect on the graph. So I've said this in the last video, I'm going to say it again. I think Desmos is very useful for seeing how this kind of stuff works. So the effect that each of these roots has on the graph is determined by its multiplicity, the power that's with that root. Okay, so let's see, I need another color green. So it depends on whether that multiplicity, that exponent, is even or odd. Okay, so if this root, which root has even? This one. So at x equals 1, we know it's a root. We know it's going to hit 1 on the x-axis, right? So if it's an even, which it is, it's 6, has a multiplicity of 6, has an even multiplicity, then the graph is going to it's going to hit x equals 1, it's going to hit that root, then it's going to bounce back off the x-axis and go back where it came from. Okay, so just bear with me here. So I'm just going to write it's going to bounce off axis. Okay, it kind of looks like once it hits that root, it goes back down kind of like a parabola shape a little bit, which makes sense because if it's even, like 6, then it makes sense because x squared is a parabola, which is even, and this is just a times 2 times, or plus 2. It's even, so it's representing that parabola shape. Sometimes it's easier just to remember, okay, it bounces off. So for odd, it doesn't bounce off let's see here, at like negative 2/5. It's not going to hit negative 2/5 and bounce back off. it's going to go through -2/5 and shoot right through and go to something else. So I just explained this as cross through. Okay, and again, that's all determined by its multiplicity. So really quickly, let me just pull Desmos to show you guys how this happens. So I'm just going to graph this first equation here really quickly. 3x. I get really scared that I'm not actually recording to keep making sure. Raised to the 6th. 5x plus 2 raised to the 3rd. Okay. So what I mean by bounce off versus going straight through. So we said that since this root had an even multiplicity, that it should bounce off and make that parabola-like shape. Okay. So look. At the root 1, do you see how it hit at 1, but it bounced off and went somewhere else? Now for that -2/5, since it had an odd power, we said, okay, well, it's going to go straight through. Well, let's see. So here's my -2/5. Okay, and do you see how it went straight through and went and did something else? It didn't bounce back off and go back where it came from. It went straight through. So I don't know if that's proper terminology to use for the effect it has on the graph, but that's pretty much what it means. Is it going to make that little loop shape, or is it going to go straight through and continue with the graph? You'll know based on the power, the multiplicity here. Okay, so that'll help you for the top half. Now, for the bottom half, we're talking about end behavior again. Okay, so it says the end behavior of a function can be determined by the sign of the leading coefficient and whether the function is even or odd. Okay, I think you guys have learned how to determine if a function is even or odd, but I'm just going to really quickly discuss it again so that we're all good. Okay, so let me think of, okay, a function, let's say f of x equals -3 plus 2x. Okay, so if I plug in a -x, whatever pops back out is going to tell me whether it's even or odd. And what I mean by that is, if I plug in -x to this equation up here, I just change this to a -x and simplify. If I get back out the same exact thing, it's even. If I get back out the equation, but completely opposite signs on both terms, all terms, odd. Okay. If it pops back out where only 1 has changed, if it ended up being -3 minus 2x, it's neither. So you have to pay attention to the sign switch. What happens to that equation if you were to plug in a -x? Okay? So it's determined by whether it's even or odd, and the leading sign of the leading coefficient, the sign on the leading coefficient, okay? So it wants you to sketch out these 4 functions, because it will actually kind of help you in determining. So I have another graphic that I would like to show you that's a little cheat sheet to figuring this out, but I think it would be helpful if we run through these equations quickly. So it wants us to do x to the 3rd, -x to the 3rd, x to the 4th, and -x to the 4th. So if you notice, we have all the different combinations here. So we have evens and odds, and we have them with and without leading coefficients being negative. Okay, so let's sketch them. So we know that this first one looks like a weird S shape. Okay, and then when it's negative, it flips it. So now it looks like. Okay, x to the fourth kind of looks like a parabola, but not quite. But that makes sense because x squared is a parabola. So it's a little bit flatter on the bottom. Looks exactly like a parabola. Awesome. Okay. And then this one is just flipped over. Okay, and if you see, if we were just looking at these and we were determining the end behavior, the whole, as x approaches positive infinity, what are my y's doing? And as x approaches negative infinity, what are my y's doing? You're going to get the 4 different combinations. And what I mean by that, I'm going to show you another graphic that you should pause and write this down or take a picture of it or something. So, if the degree is even and the leading coefficient is positive, here's what my end behavior is doing. Okay, and we have all 4 combinations. Okay, and if you notice, we have all of these up here. Odd, positive, odd, negative, even, positive, even, negative. So these 4 graphs represent this table here. So this is going to be a good resource to use on at least the bottom 2 questions. So it wants you to look at these graphs and determine whether it's even or odd and the sign of the leading coefficient. Okay, so what we're trying to figure out is whether it's even, odd, positive, or negative. So it wants us to figure out these first 2 columns. So we need to first figure out, just by looking at the graph, what's the end behavior going to be, and then we're going to work backwards on this table. Okay, so we can see here that on this first graph at least, so as my x's are going to positive infinity, you can see here my y's are going to negative infinity. And as my x's are going to negative infinity here, my y's are again going to negative infinity. So I'm just going to match up that scenario with my table here, and it's going to tell me whether the degree of that function is even or odd and what the leading coefficient's sign is. So with that scenario, it ends up being even and negative. So this table was pretty helpful in remembering all of that. Okay, so that's all I'm going to do for this video. So I'll see you in the next one.